What's up, Algebra 2 class? Again, sorry I couldn't make it. I'm not feeling too hot, but like with all other classes, the show must go on. So in your notes, we're going to kind of quickly go over the parts of stuff we didn't get over yesterday in terms of transformation. So this is section 11.2, right? Transformations. And we talked about what a transformation is. You have that in your notes. I'm not going to rewrite all that out. But to quickly recap, we had two types of transformations. You had the additive transformation, which we talked about with that spacesuit example. Right, so we had our mean, median, range, mode. By number summary changes by the amount added. So when we found the mean, median, and mode for all that other stuff, right, all we had to do was add 250 to it. And the things that stayed unchanged, okay, were everything that dealt with spread, right? So we could have thought of having this data and dragging it along. We're not stretching it or shrinking it. Everything just moves because in the spacesuit example, we added 250 pounds to everything, right? So unchanged includes standard deviation, right? Because that measures spread. If we're adding everything to 250, the data doesn't become more spread out. Everything becomes bigger, but the distance between all the data points becomes the same still, right? So things that don't become changed are standard deviation and range, right? So those two things remain unchanged. So that was a big takeaway, okay? And that was the first type of transformation we did. We talked about that. The second one that I want you to talk about, or that we need to talk about, is multiplicative. Okay? And this sounds just as straightforward as it is. So in number one, we added to everything. In multiplication, we're going to actually multiply the values. So let's try to think of an example. I want to stick with stuff we've seen before. So my first example here is going to be income again, right? And I'm going to use really convenient numbers. This is income in thousands. So, right, this 10 represents 10,000, 20,000, 30,000, 40,000, and 50,000. We're not going to do it any outliers here. It's, a bit of a hassle. So, with that in mind, we can really quickly find our 5-number summary, okay? Min is 10. Q1 is 20. Median is 30. And in fact, I can just erase this and write it out above it. Save ourselves some time. Right, so this is our min. This is my Q1. This is my median. This is my Q3, and that's my max. So these are things we already know, right? Okay, so let's say I want to travel to Europe, and I want to figure out, well, maybe they have the same income spread as Americans. This is not necessarily true, but just for funsies, let's just say I wanted to convert this to euro. And I forgot the symbol for euro, but like you would put $sign for this, you'd have the euro sign. I think it might look like that or something like this. I think it looks like that. I think that's the euro symbol. Something like that. Anyways, we're going to convert to euro, and we're not adding because, think about it, if we're converting something, we're actually scaling it. And the interesting thing about the euro is that it's actually worth more than the dollar. And another way of saying that is that $1, when we have our exact currency rate, is equal to 0.86 euros. So, with that in mind, if I want to convert this entire data set, right, we could think of X is our income in dollars. And let's say I want to get Y is my income in euros. Okay, so what I need to do is make Y equal to X times 0.86. Okay, so at this point, I'm going to multiply everything here by 0.86. Okay, I thought I had my calculator. Give me a second, folks. Alright, so when I multiply this out, okay, this is going to become 8.6 thousand euros, right? Because I multiplied 10 times 8.6. I'm going to multiply 20 by that. I'm going to end up with, I might be able to do this mentally, 17.2. Okay, for 30, I'm going to add 8.6 to that. Let me just make sure I'm doing this right. On my calculator, you can follow if you like, but you should still be getting this down. Okay, so I multiplied 30 times 0.86, and I end up with 25.8. Okay. What I'm going to do again is multiply 40 by 0.86. Right, so the idea is that I'm applying a multiplicative transformation because I'm multiplying every single data point in my set by 0.86, right? Because I want to convert every single dollar amount here to euro, right? So this is a completely new data set, okay? And then let's do it for 50, and we'll be good to go. All right, and I get 43. Okay, so that's my data set in euros. So I just converted it to thousands of euros, right? Now, to the side here real quick, I'm expecting you to know how to compute this, but I'm doing it on my calculator for the sake of time, okay? Our mean, right, is going to be the sum of all these over 5, okay? So that's going to give me, give me a second, folks. Okay, that's going to give me 150 over 5, which in fact equals 30. Alright, so that's 30. Okay, and my standard deviation, again, I'm going to do it on my calculator. Give me a second. I got to enter it in. All right. So when I compute my standard deviation, okay, I'm going to end up with a standard deviation of, oh shoot, it didn't come out right. So I'm wasting time here. So when I do it, I get well, I had this plan. There we go. Okay, so when I do this, I end up with 14.14. So my standard deviation is 14.14. Okay, so here's a big takeaway. If I want to find all this stuff again for my new data, so let me just draw this blue line. Okay, so that's our old data. This is our new, but we have this scale factor here, right? It's similar to the additive transformation in that we don't have to compute all this again to find it, right? We found our 5-number summary up here, and we found our mean and standard deviation right here. Well, to do that for this data, we're just going to multiply everything by this 0.86, right? For additive, we added it to all these, our 5-number summary. The standard deviation didn't change. Well, think about it. Because we're actually multiplying all our values, our standard deviation is going to change by that same factor. Same thing with the mean, right? So, if we want to find the min, right, that would be 10 for my original times 0.86, right, which is actually 8.6, right? And you can see how that works for each of these, right? I'm going to multiply, to get 17.2, I multiply 20 by 0.86, right, and so on and so forth. The big difference here is when we're doing our mean and standard deviation. So when I do my mean, right, I already found out my mean was 30 earlier, so all I got to do is multiply 30 by what? Give you a second to talk amongst yourselves. We multiply it by 0.86 because that's what I multiplied everything by. Okay, and that's going to give me 25.8. Right, so this is my mean now in euros, right? This is my mean household income in euros, right? Assuming that the data is the same between countries, I just want to convert it to euros to show how we're multiplying this. Standard deviation, right? We don't have to go through building that massive table again and doing all this work. We know that our first standard deviation was 14.14, and I'm going to multiply that by 0.86, right? If all my data is going to shrink a little bit because I'm multiplying it by a decimal less than 1, same thing's going to happen to my standard deviation. Okay, so that is going to be equal to 0.86, actually. That's going to be equal to 12.1604. Okay, so that's my new mean and standard deviation. Okay, and the same thing for range. My range here was 50 minus 10, which is 40. I'll multiply 40 by 0.86, okay, to get my final range. So again, for multiplication transformations, we multiply everything by that 0.86. For additive, right, standard deviation stays the same because we're adding to all the values, so the spread stays the same. For this one, I'm actually changing the spread because I'm multiplying everything by a certain amount. I'm not just shifting it, right? You could think of this being my data, and I'm shrinking it to a factor of 86%, right? So I started here, worked here. Whereas for additive transformations, I'm actually sliding the data to the left or right depending on whether or not I'm adding or subtracting. But the spread stays the same, right? All right, folks. Miss y'all. Sorry I couldn't make it again. If you have questions before the test on Thursday, I'm still planning to have it on Thursday, send me an email. I'll do my best to respond to you, and the teacher, the sub, will give you the assignments to work on for today. I hope y'all get through it. All right,